1.638, load case 19. So 1.638, okay, I'm saying okay, yes, it's about 11, because if you look at this, approximates to 3 decimal points. If it's to 4 decimal points, if you change your into 4 decimal points, it will give you 11. You can see this is about 11 points. It will give you that 11, approximately 11. So this gives you the analysis engine results based on analysis engine without approximation. But the environment, I put into approximation to 3 decimal points. That's why you are seeing that result. So critical performance is 11.07 at this distance. So it gives you the reinforcement. So what it's telling you here now is that we need 5 T16. Because look, at height 43, you need 3 T16. At height 75, remember this is a 230 by 400. So this is still a bottom reinforcement. How do you know? Okay, 43 minus 75 will give us 32. So what is just telling you that from this 43, if you add half of this 16 mm, so half of 16 is 6 plus half of 16 again, so it's the spacer between this bar and this bar is a 16 mm bar. So you have transverse spacer, which is 16 mm. So if you add that 16 mm to another 16 mm, you have 32. That gives you this bar. Let me explain a little bit better in details using a drawing. So what STAAD is saying is, if I have okay, so if this distance from here to here is 43, now STAAD is positioning the next bar that you require. It says the first bar you require is saying is 3T16 at 43. At height 75, you need 2T. So here you need 3T. It gives you another height that you need 2T. So one may ask, how did you get the second height? So here, from here to here is 43. Then here to here to here is 32. 32 plus 40, what is that? Plus 43 will give you 75. So the spacing between the two is the spacing of a spacer bar, which is the same as the size of the reinforcement. So once you have this as 43, this first distance from here to here, 43, it then positions the spacer bar and then in your location of the next bar. So it tells you need 5 T16, and then it gives you the moment that is causing that. So the critical positive moment, it gives you the location where you also even need this bar. It tells you that, look, this bar is not needed at this location. Look, it's needed from 0.117 to 3.485. Okay, 0.117 to 3.185. Let's see. To 3.185. Zero 0.46. So the span of this beam we call is 3.9. So it's giving you the location of your flexural bending sagging moment reinforcement. So it tells you the critical positive moment is 11.07. It tells you where you need this reinforcement. You need it from 0.117 to 3.485 meters. And then this other one, you need it at this location. So you need 5T16 at that location. Critical point moment is 11.07, and it occurs at 1.638. The required area of reinforcement is 886. Okay. The percentage reinforcement is this. The percentage of reinforcement is what he has calculated now within the cross section. So how is this obtained? Let's look at how that is obtained. So T16 5 give me let me see 4 Okay, so this is AS required from design. Okay, this is AS required, and then AS provided. You look at what AS provided is 1005.31 millimeter. That is 5T16, which I had calculated. Okay, so this AS required, and so what it has provided is more than AS required. Okay, then if you look at divide this by 230 divided by 230, so if you remember, so this is the required steel, this is the minimum AS required. Remember, the code says that the minimum AS required is 0.04% of the cross section of concrete. Remember, now if you look at good, so if you look at what the code, what this has done, good. So now it tells you this is the AS required from design. This is the percentage area of reinforcement in the concrete. Remember, the code states that the minimum AS required is 0.13% BH. Remember, let me write that out. The code states that you need 0.13% BH as your AS minimum. So the minimum AS required is 0.13% of the cross section of the concrete. Now, the concrete size is 230 by 400. Look at what STAAD has done. So from the analysis, from Benjamin diagram and so on, it's telling you that the AS required is 886 millimeters for that 230 by 400. Now, he then provided 5T16, and truly, if you check 5T16 from calculation, it gives you an AS of 1005 millimeters, which is more than the AS required, which is fine. Now, what this means is this is now checking the percentage of reinforcement within the concrete cross section. So 886 divided by 230 divided by 400, it gives you 0.96%, which is exactly what you have here. It is correct, and it now tells you what the minimum percentage is, and then what the maximum percentage is. Sorry, this is the maximum percent, this is the minimum percentage. Minimum is 0.2%, maximum is 4%, and then we have 0.09, so we are fine. Then it tells you what the maximum, minimum, actual bar spacing is. Then it gives you top reinforcement 350 at height 350 around this. You need 2T16 and 2, so you need 4T16 from 0 to 865 millimeters. That means 0 to 0.865. You need 4T16. It also gives you a critical negative moment 9.01, which is true. If you look at this 9.01, which is fantastic.